the basics again. Let's get rid of U and get started on U. Oh, negative exponents. What's a negative exponent? A negative exponent simply means that whatever side of the fraction bar it's on, you move it to the other side. So let's take a look at this first one. It is on, well, there is no fraction bar, so how can I move it to the other side of the fraction bar? Oh, I know. I'll make a fraction bar and put it over 1. Whenever you have a negative exponent, you move whatever the negative exponent is attached to the other side of the fraction bar and make it positive. So 6 to the negative 2 goes downstairs and becomes 6 to the positive 2. And since I have nothing left upstairs, I'm going to keep a 1 there. That's what I do with negative exponents. What do I do with 0 exponents? Well, anything to the 0th power is 1. So anything to the 0th power is 1. Anything to the 0th power is 1. So 1 times 5 to the 3rd is just 5 to the 3rd. Or you could have added the exponents here, and 0 plus 3 is 5 to the 3rd. Either way, it's all good. It's all good, baby. It's all good, baby. Okay. No big deal. I can do this. Positive exponent and a negative exponent. Anything that has a negative exponent gets moved to the other side of the fraction bar. So if I don't have a fraction bar, I make a fraction bar like so. Take a look at that 9 to the 4th. Does it move or does it stay? It stays because it has a positive exponent. Take a look at that 9 to the negative 4th. Does it move or does it stay? It moves because it has a negative exponent. Any number divided by itself is 1. So 9 to the 4th over 9 to the 4th is 1. Dunzo, dunzo, dunzo. Don't overthink it, don't overthink it, don't overthink it, don't overthink it. Okay, let's do it again. Negative exponent over 1. Do you move or stay? Well, you stay because you have a positive exponent. You move because you have a negative exponent. So this is different. We haven't run into this issue yet, but it's actually a pretty easy issue. Whenever you divide powers of the same base, subtract the exponents. Well, in this case, the more powerful exponent lives in the denominator. So when I subtract, I'm going to have more 2's in the denominator, so I'm going to keep those 2's in the denominator, and I'm going to have 1 up top in the numerator. Okay, whatever number is more powerful, you keep it there. Negative exponents again. So I'm going to put everything all over 1. Do you move or do you stay? You move because you have a negative exponent, so I'll put 3 to the 3rd downstairs. Do you move or do you stay? You move also because you have a negative exponent, so I'll make it a positive exponent and put you downstairs. There's nothing left on top, so I'm going to put a 1 there. When you multiply powers of the same base, you add the exponents. So I would have 3 3's and 2 3's next to each other, so I would end up with 5 3's total. And that's what you get. Oh, same types of problems. If you divide powers of the same base, subtract the exponents. The 4 on the bottom is more powerful than the 4 on the top. There's 3 4's up top. There's 5 4's on the bottom. So you're going to keep your 4's on the bottom, subtract the exponents, and since you completely eliminate the top, you keep a 1 up there in the numerator. Oh, look, a negative exponent downstairs. When you see a negative exponent, you move it to the other side of the fraction bar. So that negative exponent moves to the top, 5 to the 3rd, over 1 times 1 over 5 to the 6th. That 5 to the 6th doesn't move because it has a positive exponent. When you multiply fractions, you multiply straight across the top and straight across the bottom, which means I'm going to have a 5 to the 3rd up top and 5 to the 6th on the bottom. Nothing really changes at all, really. When you are dividing bases, are dividing powers of the same base, subtract the exponent. The 5 on the bottom in the denominator is more powerful, so keep it there because that one has 6 and that one has 3. Subtract the exponents, leave a 1 up top, and there you have it. Sorry. Sorry. All right, so I have 3 things going on in this fraction. Do you move or do you stay? You stay because you have a positive exponent. Okay? Do you move or do you stay? You move because you have a negative exponent, so I will make it 1.5 to the positive 2 upstairs. Do you move or do you stay? Let me choose a different color. Do you move or do you stay? You stay because you have a positive exponent. I have two 1.5s next to two 1.5s upstairs, and that's going to leave me with four 1.5s at the exponents. And on the bottom, you still have 1.5 to the fourth. Now, in a previous problem, when we had something to the power and the same exact thing in the denominator, you just get 1 because something divided by itself is 1. 1 to the fifth to the fourth, 1.5 to the fourth divided by 1.5 to the fourth is going to be 1. So this guy just becomes 1. And my face is in the way. My face is in the way. My face is in the way. Why can't you get smaller? There you are. Okay, there's a negative exponent, so I move it to the other side of the fraction bar. Oh, this guy doesn't have a fraction bar, so let's make one. Do you move or do you stay? You move because you have a negative exponent, so let's move you downstairs. Do you move or do you stay? You stay because you have a positive exponent. And I have different bases. So am I going to do any 7 minus 2s? No, because the rule is if you're dividing powers of the same base, subtract the exponents. I'm dividing powers of different bases. One's an A, one's an 8. They're different. Don't do anything. You're done. I have 3 things. I have a 5. I have a b to the negative second, which moves downstairs. It becomes b to the positive second. I have b to the negative third, which moves upstairs and becomes b to the positive third. I have a 5 and nothing else. When you divide powers of the same base, subtract the exponents, the b upstairs is more powerful, so I'm going to keep it up there. So that becomes 5b. 3 minus 1 is, or 3 minus 2 is 1 over 1. There's 2 things here that I don't need. First off, I don't need b to the first, so I'm going to keep it as 5b. Because there's just one b. Why not write out 1b? And when I divide by 1, I just get the answer anyway, so I don't need the over 1 part. You never need an over 1, but you do need the 1 if it's in the numerator. All right, so a bunch of things here have the potential of moving. Let's check them all out. 3 to the negative 2, you move to the bottom because you're a negative exponent. K to the 0th, you stay up top but become 1 because anything to the 0th power is 1. W to the 0th, you stay up top but you become 1 because anything to the 0th power is 1. And last but not least, W to the negative 6, you move upstairs and become W to the positive 6. So look at upstairs, look at the numerator. 1 times W to the 6th is W to the 6th. 3 squared is 3 squared. Do the W to the 6th and the 3 squared combine? Nope, because they're different. And that's what I get. So those are 0 and negative exponents combining with the other power product, quotient product rules that we had the other day. Pretty excite. Pretty excite. Bye.